Hello, welcome to a statistics presentation. We're doing problem number 5. Says consider a test. Null mean is equal to 75. Performed with the computer. The software reports a two-tailed p-value of 0.1032. Make the appropriate conclusions for each of the following situations. What they really want us to do in this situation is to treat each one individually and just determine whether we're going to reject the null. If we reject the null, that means we have sufficient evidence to reject the null. And if we fail to reject the null, which means we have insufficient evidence to reject the null. Okay. First thing I want to do is look at part A. Mean of 75. That's your alternative, so I know it's a left-tailed test. So mean is less than 75, so it's a left-tailed test. And my z is negative 1.63. I think the easiest way to do this, you could find the critical value for each one and reject that way, or you could find the p-value and reject. Remember, if p is less than alpha, you reject. So let's find the p-value. I think it will be easier. So I want to look at negative 1.63 and then find my p-value for this z test statistic. So I go to mini tab. I'm going to go to graph, probability distribution plot. I'm looking for view probability. This stays normal. And here I'm looking for an x value, and I'm looking for left tail because it was less than. So I'm going to go negative 1.63. Okay, the area to the left of negative 1.63 is 0.0515. We are comparing that 0.05, that's like a nickel, that's your p-value, and I'm comparing this to my alpha value of 0.04. Which one is smaller? Remember, if p is low, the null has to go. Well, in this case, the p is actually greater than my alpha, so in this case, I have insufficient evidence to reject the claim. So I'm going to click on this one. Great job. Alright, next one. Mean is less than 75, so it's still a left-tailed test, but notice they have z is equal to 1.63. It's still a left-tailed test. Well, what's going to happen here, my 1.63 is on this side, so I really don't have to run the test, but since I'm doing it, I'm going to go ahead and run it. So 1.63 here, here, here. It's a left tail test, but this time it's positive 1.63. It's still left tail. Notice how large my p-value is. It's almost the entire under the curve, 0.9484. So with that one, definitely without a question, it's greater. So this one is definitely there is insufficient evidence. The next one. Greater than 1.63, and my z value is 1. So we're looking at the right side, and maybe you can start to see where the numbers are going to come from and understand. But this is on the right side, and we're looking at this area. Well, this area is that other area that was on the left side that was less than negative 1.63, because remember, it's symmetrical. It was like 0.05 something. So let's compare the 0.05 to my alpha value, and I have 0.07 this time. Remember, this case looks like my p is less than the alpha value, so therefore you're going to reject the null and you have sufficient evidence. Okay, last but not least, same logic. This is a not equal to this time. It's a two-tailed test. We're going to use the p-value that they gave us. Well, it's 0.1032, and I have 0.01 as my alpha. This one you don't have to look up. If p is less than alpha, it's not. It's greater than alpha. So since p is greater than alpha, we have insufficient evidence to reject the null. And that's it for number 5. Again, that problem was a little different, so I just wanted to send out a video to make sure that everyone understood how to do this.